Hello class, today we're going to do chapter 5 section 3 bisectors of a triangle. Our goal will be to find equal segments and angles with perpendicular and angle bisectors and triangles. There's a little soccer problem with angle bisectors you can take a look at. So we're going to start here with concurrency of perpendicular bisectors of a triangle. Lots of kind of new words that we are not used to. Let me go one slide ahead and figure out what concurrency means. Concurrent lines are three or more lines that intersect in the same point. And then the point of concurrency is basically the point where those three lines intersect. So again, you're going to find a point of concurrency, which is just the point where the three lines intersect. Okay, so back to the concurrency of perpendicular bisectors of a triangle. The perpendicular bisectors of a triangle intersect at a point. So first, before we get to the rest of this, let's figure out where that point is in our picture here. So we have point P right here. That's the point. But again, what are we looking at here? We're looking at the perpendicular bisectors. So on this side, this is a perpendicular bisector. On the bottom here, AC, right here, this is a perpendicular bisector, and it extends up. And then on this side, AB, this is a perpendicular bisector. And where do those three perpendicular bisectors, you could see I'm going over them lots of times, where do those intersect? Right in the middle there. And that is your point of concurrency, and that point is equidistant from the vertices of the triangle. So this point is the same distance, is an equal distance to point B, as it is to point A, and as it is to point C. So point C over here. So you could see your result right here. And P is also called, there's a term for this, it's the circumcenter of the triangle. And we went through this. The circumcenter of the triangle can be on the inside, on the triangle, or outside. It depends what kind of triangle it is. So acute triangles are on the inside. And this is going to be important, so it might be good to write this down. Right triangles will be on the triangle, and obtuse triangles is on the outside. Now let's go back to our example. What kind of triangle is this here? Well, all the angles are acute. It's not a right triangle or not an obtuse. So all the angles are acute. So where's the point of concurrency? It's inside the triangle. Boom, 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 boom. So acute triangles, it says inside the triangle. You could see that matches up. So that's a good thing. Alright, then here's kind of some application problems. You could kind of look through this. E is the circumcenter. Again, since it's a right triangle, notice it happens to be on the triangle. Your point of concurrency ends up being on the triangle. And here we have DA congruent would be with DB. BF with FC. And then angle EFC right here. Well, that's congruent with a lot of different angles because we're forming lots of different right angles here. Alright, then we have a new one, concurrency of angle bisectors of a triangle. Before we said perpendicular bisectors. So here the bisectors of the angles of a triangle are concurrent at a point. So let's just look at that point. It's point P. And we're looking at the angle bisector. So here's an angle bisector. Then here's an angle bisector. Here's an angle bisector. We have our three angle bisectors. Where are they meeting? Right in the middle here. And that point is equidistant. It's also called the incenter, but it's equidistant from the sides of the triangles. So this point right here is the same distance, equal distance to the side of the triangle here, side of the triangle here, and side of the triangle here. So your result is PD equals PE, which equals PF, as shown in the triangle here. And again, that's called the incenter of the triangle. Alright, then just a little example. Which segments are congruent if we use the angle bisector theorem? So we're going to assume this angle is bisected, this angle is bisected, and this angle is bisected. And your point of concurrency is point S. And then we said, alright, what segments are congruent? Well, SR would be congruent with SQ with SL. And a little mini quiz finishing up the lesson here. The point of concurrency of the angle bisectors is called the incenter. There's a gift for you. You got the answer. The next ones are blank, though. If three or more lines intersect at the same point, the lines are blank. Well, that'd be concurrent. That's what concurrent means. And then the point of concurrency of the perpendicular bisectors of a triangle is called blank. So you try and think about that, figure that out, look at your notes. It's the circumcenter of the triangle. So that is all for today. You could see my computer's messed up, as you can see it kind of being weird now. So anyway, you could buy me a new computer if you want, but if not, I'll see you in class the next